All right, boys and girls, welcome to Physiology for the Uninitiated. Really quickly, I really want to talk to you about Zone 2 cardio and why we should do these sessions every single 70% of the time. So, with Zone 2 cardio, we're doing something really interesting because the mechanism of action with Zone 2 cardio is that you're pulling glucose, you're breaking down glycogen into glucose. The glucose then enters the cell and into the mitochondria. So then it could then go down into the mitochondria to enact itself, into the mitochondria to go down this mitochondrial matrix, right? When it goes into this matrix, it does something called, or it goes down what you call the electron transport chain. After ATP is extradited from the electron transport chain, which we can dive into later, because it's a whole series of mechanisms that's going down that's creating energy, adenotriphosphate. So in the event of a glucose, remember it's from the glycogen of the body getting broken down. It's that subcutaneous fat. We'll think of it that way. Gets broken down into a glucose molecule. Glucose molecule goes into the mitochondria, gets spat out as an ATP or ADP. When a proton attaches to ADP and makes ATP, adenotriphosphate, adenodiphosphate for ADP. When it makes ATP, it goes to the muscle, and in the actin and myosin, chain within these muscle fibers, it will attach, and then the actin and myosin will then contract with one another, right? So we're creating energy more effectively with less or little to no lactate. The interesting thing about Zone 2 cardio, specifically Zone 1 and Zone 2, is that when you're in that 70 percentile of your max heart rate, which is what Zone 2 is, so that's 70% effort. And this isn't a 70% muscular effort. This is a 70% heart rate effort. Good rule of thumb. And if you wanna roughly guesstimate this, I've heard Peter Attia say you have to be running or cycling or rowing or maybe not swimming at a pace at which you could hold a light conversation with struggle. So every third or fourth breath, yeah, that sounds good. All right, I'm coming back home. And you're in a rhythmic sense breathing, all right? And if you disrupt this pattern too much, you're not going to be exchanging oxygen well enough through your respiratory system, and you're going to start getting more exhausted, and then you're going to have to slow down. That's where you're at with Zone 2 cardio. So that was like a really quick physiology recap for those of you that haven't taken biology class here lately, or have been out of high school or out of the education system for a while, and maybe you don't watch mitochondria videos. So with that out of the way, and establishing what Zone 2 cardio is and what it feels like, and a good rule of thumb, also you could take your age, subtract it by 220, and then, or subtract 220 by your age, and then divide that by 70%. That should give you a rough estimate as to where your heart rate should be for that particular effort. Correct me in the comments if I'm wrong. So establishing all of that, what's going on with your body, how is it differentiated between like lifting weights? So lifting weights is what we call anaerobic, and zone 2 cardio, or any sort of cardio that you do, is aerobic. So anaerobic, aerobic. Anaerobic is AEN, aerobic is no aerobic. So with anaerobic, there is not as much of a heart and what is anaerobic? There's no cardiovascular effort, excuse me. So when there's not that much cardiovascular effort with anaerobic, we're going to secrete out of the mitochondria something called lactate. And lactate is what makes your muscles stop contracting because it becomes too painful. It becomes too acidic here in this bicep, even in an isometric hold like this. Eventually, I'm going to have to let up, go into eccentric phase, and then completely rest. And that's what differentiates the two, is that lactate gets secreted with the anaerobic movement, which is really interesting because lactate also signals for muscle growth. So we have a very interesting conversation to have here. You could do something like aerobic-based training after your anaerobic-based training, where you build up a bunch of lactate, you feel really sore, lactate turns into lactic acid, and you have all this lactic acid stored in the muscles, which is making you very sore. If you do an aerobic session right after the lactate heavy session, you could then, with your body, shuttle out. This is the incredible thing about aerobic capacity, is that if you have a really trained aerobic system, you could shuttle out the lactic acid buildup effectively enough that you could then proceed to keep moving. It's kind of like a combat override. It's like, hey man, we gotta keep going. We gotta keep moving forward. And this will further break down any more glycogen that you have, and we will go so far as to say you can stay in an aerobic state until you are completely out of fuel. What does this mean? By fuel, we're at 8 minutes. By fuel, I mean your glycogen stores, which is stored as in the form of triglycerides and in adipose tissue. Adipose is fat, and visceral fat. Once you're all done pulling from those glycogen stores, from that fatty tissue, we then go into the muscle. And when we go into the muscle, we start burning what's called amino acids. And then from there, we will go into the bone. And this takes a long time to do. It's not like you can't do this in one workout session. We're talking about starvation at this point. So good rule of thumb, you're always cellularly respirating. You're constantly going through cellular respiration. We're constantly going through thermogenesis. We are constantly, the laws of thermodynamics are constantly in play. This is where your cells are constantly feeding on something metabolically. So it's a good rule of thumb, and it's really important to understand. You can keep going. You can keep going aerobically. There does come a point where there's diminishing returns. So you should be very smart with how you train, because you can certainly train to the extent that you have no more muscle on your bones, and you're sarcopenic, and then we start digging into or endangering our bones, which lead you to osteoporosis. Really interesting conversation to have. Anyways, So those are the delineating factors between anaerobic and aerobic training. Aerobic is cardiovascularly based, and you could do for many repetitions. Anaerobic, you're going for anywhere from 1 to 30 repetitions, and really a good way to delineate between the two is you could do one for timed. Your repetitions are timed with aerobic, and then with anaerobic, it's just like a set number that you're shooting for, because the weight's incredibly difficult to move. So that's the delineation, and you should be doing aerobic training 70% of the time. 70% of your training should be zoned to cardio. This will give you a body recomposition, and you'll start shedding fat. You might even start losing muscle. It's a really great way to cut down the pounds, and this is something that you can really take advantage of to increase heart health. This gets overlooked a lot of the time. People are afraid to run. People are afraid to do long endurance style training. But if you want efficacy at your mitochondria, which is contained inside of your muscles, it's this little guy right here. The more you train in an effort to make those more effectively, the better your overall health. And we start seeing this in other health metrics and whatnot. So really interesting stuff to look into.